Hello and welcome to York Observatory's monthly TeleTube broadcast, the online astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. We are broadcasting live from the Alan I. Carswell Observatory located at York University in Toronto, Ontario, Canada. York YouTube broadcasts every last Friday of the month at 7:30 p.m. local Toronto time. For any questions or comments you have of our past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Instagram with the handle at @yorku_observatory. We would like to inform you about the opening and call for applications for the Summer 2025 Astronomer in Residence program. This program is a collaboration of the Alan I. Carswell Observatory with Killarney Provincial Park to host astronomers in the certified dark sky side of Killarney, to lead in-person presentations and shows using the park's observatory. To learn more about the program, its requirements, and the application process, visit our website at yorku.ca/science/observatory/air. Good evening, everyone. I'm Maheen, and I'll be one of your hosts this evening, along with Darius, Pablo, Daniel, Boris, and Hector. Tonight, we've got a wonderful guest speaker, Camila Guzman, joining us, whom we will be introducing shortly. The observatory at York campus is in Toronto, and we would like to welcome you all to our show and to acknowledge the traditional land that our telescope is on. The observatory acknowledges its presence on the traditional territory of many Indigenous nations. The area known as Toronto has been caretaken by the Anishinaabe Nation, the Haudenosaunee Confederacy, the Huron-Wendat, and the Métis. It is now home to many Indigenous peoples. We acknowledge the current treaty holders, the Mississaugas of the Credit First Nation. Our stargazing and astronomical efforts join the long history and current practices of astronomy for this land. The observatory looks forward to continuing to learn and revitalizing our knowledge in this area. So without any further ado, I will hand it over to Darius, who will start us off with the What's Up Tonight section. Take it away, Darius.
Thank you, Maheen, and welcome everyone. Before we get started with our main show, we want to give you a little update on what you can see this coming week. This week, we have Mars, Jupiter, and Venus visible at some point throughout the night cycle. To local observers, Mars can be seen high in the southeast sky around this time at a high altitude of 70 degrees. The same goes for Jupiter, though it will be southwest at about 60 degrees. Observing Venus may be a little trickier as it will appear fairly low in the sky. Look west shortly after sunset and it should be visible. We just had a new moon a couple days ago, so it's rather hard to see, and it also currently rises in the morning and sets a little after dark, meaning this is not a good week for the lunar observers among us. Some notable stars to look out for include Betelgeuse, a red supergiant star that is growing quite old and has a distinct reddish hue. Search for the Orion constellation in the south sky and pinpoint the red star to the up and left of the belt. Also look out for Sirius, the brightest star in the sky, excluding the sun. It will also be due south, about 25 degrees below Betelgeuse. Since it's close to us and has a naturally high luminosity, it stands out among the crowd. All objects mentioned can be seen easily with the unaided eye, though any with some observation gear who reside in lower light pollution areas may be able to catch a glimpse of the Andromeda Galaxy, the closest and brightest neighboring galaxy. It will be northwest at an altitude of 40 degrees. Now our main speaker will be introduced.
Thank you, Darius. Hello, everybody. I'm going to be introducing our speaker for tonight. Her name is Camila Guzman. She's a fourth-year undergraduate in physics and astronomy at York University. She's been working at the observatory since 2022, and she's held positions such as work study and student coordinator in the past. Now she's a research student at the observatory working with Dr. Hyde on variable stars. Currently, she's the only undergraduate student holding the observer certification of the 60 centimeters and 1 meter telescope. And she's also working on the Explorer program with Dr. Cannon on supermassive black holes at high redshifts. She's very passionate about observing with telescopes, and her favorite object is the moon. In her free time, she likes to play video games and she likes to go swimming. So now, without further ado, let's welcome our speaker, Camila Guzman.
Hi, everyone. Thank you so much for the introduction. I'm going to be sharing my screen. There we go. Hi, thank you for the introduction. So, my name is Camila, and I'll be trying to answer the question of why Titan is very special. And the first thing I'm going to do is I'm going to introduce you to this moon. So, this moon is the second largest moon in our solar system, and it's actually 2% smaller than Ganymede, which is the largest moon in our solar system. So, if you think about it, it's not a very small moon. So, let's compare it to our moon. This moon is 2 times more massive than our own, and is also 1.5 times bigger in radius than our moon. So, it is a pretty big moon. Another thing that I would like to mention is that this moon is located at 9.5 astronomical units from the sun. And just as a reference, we are about 1 astronomical unit from the sun. And so that's roughly about 10 times further away than we are from our sun. And another thing is that in comparison between our Earth-Moon system, Titan is located at 1.2 million kilometers away from its planet Saturn, while we are at a distance of 400,000 kilometers, roughly, apart with our moon. So that's a pretty big distance. The one similar thing that we have here is that our moon and Earth are tidally locked in synchronous rotation, which basically means that the moon shows one face while you're standing on Earth, and the same thing happens on Saturn and Titan. So if you were standing on Saturn, you will only be able to see one face of Titan. And another thing that I wanted to mention is that it takes approximately 16 days to complete a full orbit of around Saturn, while our moon takes about 27 days. So it's a little bit different, but not that much. One thing that is extremely different is the period of rotation around the sun. So Titan and Saturn take about 29 Earth years to complete one full orbit, while we take 365 days. So they share the same axial tilt, and because of that, they share the seasons. And so one different thing that we have here is that our seasons are very short compared to Titan's seasons, because these seasons last about 7 years and a half each. So that's a big difference. So what's this moon made of? A model based on Cassini's data suggests that there are 5 important layers for this moon. The first layer is a rocky core made up of a type of silicate core rock that contains water within its mineral structure. The second layer is a high pressure water ice layer that is it's a water ice basically found on very high pressures. The third layer is made up of a specific salty liquid water. And then the fourth layer is made up of water ice. And then the last layer will be the surface with liquid, sands, and atmosphere, which I'm going to talk about that very soon. So what's special about Titan? One of the most important things and special things about this moon is about its atmosphere. It's the only moon in the solar system with a very dense atmosphere, and it is mostly composed of 95% nitrogen and 5% methane. And it extends to an altitude of 600 kilometers due to its gravity not being able to hold onto it. And so, another special thing that this atmosphere has is that it has a greenhouse effect and an anti-greenhouse effect. And how does that happen? We don't usually see anti-greenhouse effect often. So this is because of Titan's haze. So basically, the high energy particles accelerated in Saturn's magnetic field and the ultraviolet light that comes from the sun, they tear apart the methane and nitrogen molecules and they create hydrocarbons, which are like hydrogen and carbon molecules. And these molecules start to aggregate and become larger and larger until they're big enough to sink in the lower atmosphere. So they go from the upper to the lower atmosphere to around 100 to 200 kilometers above its surface. And so here we have a picture that I wanted to show. So we have evidence for this haze. Cassini was able to capture, based on using ultraviolet light, it was able to capture some of the haze we could see here. And basically it shows Titan's night side limb that was colorized to appear like true color. But the bright lines there are the haze. And so what are the consequences for this? This anti-greenhouse effect makes the surface a little bit colder, and the light that gets from the sun, it gets reflected back to space, some of it. And the next thing that we have is the greenhouse effect, which methane is primarily responsible for this greenhouse effect. And so we kind of have like this tug of war situation where we have the anti-greenhouse effect lowering the surface temperature, and then the greenhouse effect that increases the surface temperature. And at the end, we get a net increase of 12 degrees Kelvin. So the greenhouse effect wins on that. And I just wanted to show you this diagram about different temperatures around the seasons. And like I mentioned before, the seasons last about seven years and a half each. And Cassini was only able to get around 2 seasons. And it was able to measure the maximum and the lower temperature. So we have, I'm going to just translate to Celsius here. So the maximum temperature recorded is around 175 in negative, so negative 175 Celsius, and the minimum is minus 182 Celsius. So it's pretty cool still, even though you have a net increase in the surface temperature. You still have very cold temperatures compared to here on Earth. And so how's the weather like on Titan? So scientists have data that basically says that you could have very heavy rain to a light waxy snow. And this happens because the methane converts to clouds and then it precipitates as heavy rain sometimes. And then you have the other case where you have the hydrocarbons that I mentioned before condensing and precipitating as waxy snow, and they land on the surface. And this leads me to the next important feature that I want to talk about, which is Titan's surface. It's a very special one, and I'm going to start by mentioning its lakes. So Titan has lakes and seas, and primarily composed of methane and ethane, and they are located at the polar regions, and particularly in the north. And basically, in Titan, you have the same as Earth water cycle, but instead of water, we have methane. So you can evaporate and form clouds and precipitate as rain, all with methane on Titan. And I just wanted to show you some evidence for water on Titan. This is one of the lakes that was found in the North Pole of the moon. And basically, you can see the light being reflected from the lake. And this is something that you could also see if you were to be in the International Space Station, which I don't think any of us was able to have the chance. But if you were to have that, you would see the same kind of situation going on. This is the same kind of reflection on the Atlantic Ocean. And this is like hard evidence that there is a lake in that moon. And even though Titan doesn't have global oceans, um, there's no other world in the solar system aside from Earth that has this kind of liquid activity going on its surface. Another thing that I wanted to mention is Titan's dark dunes. So basically, these are dunes that are found in the equatorial region, and they are stretched by the winds, and they're made up of hydrocarbon grains. The hydrocarbons I mentioned before that were made up, sometimes they precipitate, like I said, and they end up, some of them, most of them end up in the equatorial region, and they're shaped by the winds. And these are pretty big dunes. They made up 30, not 30, 13%, sorry, of the entire moon. And they stretch for hundreds of kilometers. And it's about the size of the area of Canada. So that's about 10 million square kilometers. It's pretty big. And on average, you have around 1 to 2 kilometers wide, and it's also 100 meters in height. And I just wanted to show another picture of comparing a desert here on Earth and the dunes that they were able to capture. The scientists were able to capture by using Cassini's radar team. And basically, you could see here they're very similar, and you could see the shapes of the dunes. And on the right side you have Earth, and on the other side you have Titan, which is pretty similar and interesting. And the next thing that I wanted to mention too is the fact that there there are ice volcanoes on Titan. So instead of having lava volcanoes, we have ice volcanoes. There was some kind of activity going on that Cassini was able to observe between 2005 and 2006 around a big crater, like a tall mountain and a big crater. And there was some kind of writing going on. And when they tried to look at the data, they realized that if you have this kind of situation, it's most likely to be a volcano. And because of the structure of Titan, they were able to infer that these are ice volcanoes instead of lava volcanoes. And I'm gonna show you here one of the 3D topographies where you can see the sand dunes and then this high mountain with a crater. And basically they were able to, from there, they were able to assume that that's possibly a volcano. And this is something interesting to talk about because the evidence for cryovolcanoes may explain why the methane hasn't run out of the atmosphere yet. Because, like I mentioned before, the high energy particles and the ultraviolet light are breaking apart the methane and the nitrogen particles, and because of that, some of them well become other stuff like hydrocarbons. And in this case, why we didn't run out of that? So the one of the main reasons might be because you have um, some kind of volcano activity going on that's the source of the methane on the moon. So I wanted to end up by looking at any missions, if there are any missions in the future, because it's a very special moon and we need to go there fast. And the the next mission, it's supposed to launch in 2028. It's a Dragonfly mission, and basically it's gonna be the first vehicle that you could fly on a different planet, and it's gonna be the size of a car roughly, and it will try to investigate some of the chemistry and how it has developed over time, and if we're able to support life even. But we need to wait and be patient because it's probably gonna land at around 2034. So that's 9 years from now. So we have to be patient. And that's it. Thank you very much. That was my presentation. If you have any questions.
Thank you so much, Cam, for your wonderful presentation. I really, really enjoyed it. I'm really looking forward to the Dragonfly mission. It seems so exciting. Um, it is a bit far off, but it's still pretty exciting.
Yeah.
Talking about the Dragonfly, we actually have a question by Hector.
Hello, everyone. My name is Hector Jimenez, serial astrophysics student here at York University. And thanks so much, Cam, for such an interesting talk about Titans and all of the interesting features. And it's really, really impressive that has some similarities besides this interesting mission, Dragonfly. My question is, what challenges may Dragonfly face in landing and navigating Titan's surface?
That's a great question, Hector. So some of the issues that might happen could be while Dragonfly will go through the atmosphere of Titan, because it's more dense than Earth's atmosphere, and also it depends on the weather condition. They're planning on landing on land on during summer, but that doesn't mean that you won't get any weird precipitation going on that you might not expect. So they have to deal with that. And in the surface, like I said, you could have the weather conditions might be harsh, and then you also have to take into account the surface pressure, which is 50% higher than on Earth's atmosphere. So that's something to keep in mind.
Thanks so much, Cam.
No problem.
Hi, my name's Daniel. I'm a fourth year astrophysics student at York. And great talk. I really liked the part where you compared the dunes in Titan with Earth's dunes. That was really interesting. But I'd also like to know how the greenhouse effect on Titan compares to the one on Venus.
Yeah, sure. Hi, Danny. So like I mentioned before, the primary, well, methane is the primary responsible for Titan's greenhouse effect, and on Venus, from the research that I could gather, is like Venus greenhouse effect is due to the carbon dioxide. Um, so the atmosphere is like 95% carbon dioxide. So yeah,
I see. Thank you very much.
no
I'll pass
problem.
it on to Darius.
Hey Cam, thank you for the brilliant talk. I'm Darius, a fourth year astro student at York, as you might know. My question is about the atmosphere. So how does Titan's atmosphere compare to our own atmosphere in terms of size?
Thank you for the question. So what I could say is that from the presentation, I mentioned that Titan's atmosphere extends up to 600 kilometers. Our Earth, our own atmosphere, it extends to about 100 kilometers, so it's like 10 times um, bigger than that. Yeah. So that's something that I could say.
That's very interesting how it's so much bigger. Thank you, Cam.
Yeah, no problem.
Hello. Thank you for the wonderful presentation. I'm Pablo. I'm a PhD student in space robotics.
Ooh.
And I had a question about the Titan's atmosphere. It's really interesting, the fact that Titan even has an atmosphere. So I just wanted to ask, how did it form?
Thank you for your question. Yeah, that is a very interesting question. So the main theory is that the nitrogen came from um, the comets on the in the arc cloud. So basically, they say that it will like crash onto Titan and it will gain that it will become nitrogen and it will like stay in the atmosphere. This is like the main theory, but nothing is yet confirmed because we need more research.
Thank you very much. I'm looking forward to the Dragonfly mission. Maybe they'll find some answers.
Yeah. Any more questions?
I'm Boris, and I had a question that I wanted to ask. So you did speak a little bit about the Dragonfly mission, but I was curious, In terms of other future missions to Titan or future research in general, is there anything in particular that you're most excited about?
Yeah, thank you for your question, Maurice. While I was doing my research, I read that dragonfly would mostly land on the equatorial region of Titan, where you have the dunes, and I am very excited to see what the composition of that is, and compare it to what we have here on Earth. Maybe we could, find something that we really don't know.
Thank you.
No problem.
All right, so I happened to also sneak in a question for you. So while you were researching Titan, I'm wondering, what is one thing that you found most fascinating about it?
Thank you for your question, Maheen. Yeah, so the most fascinating thing about Titan, like for me, is that it's just a moon located so far away, and yet when you describe its features, it reminds me so much of Earth. Like the atmosphere is rich in nitrogen, like we have here on Earth. We like it has lakes and has dunes that resemble deserts. It's just so fascinating to me that it's like kind of like Earth, right? And it's so far away. Like, how can it be?
Yeah, I love that. Having a moon being similar to a planet is quite interesting. Yeah. Well, thank you once again, Cam, for coming on today and telling us all about Titan. We all learned a lot and we appreciate your time.
Thank you.
So I'll hand it over to Hector now to close us off for the night.
Thanks so much, Maheen. All right, well, everyone, you have been listening to the Alani Castle Observatory's monthly TeleTube broadcast, the online astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening were Maheen, Pablo, Darius, Daniel, and myself, Hector. All of our programs are free, but if you would like to make a donation, see our website at yorku.ca/science/observatory/. You can always connect with us on Instagram with the handle at Yorku Observatory. And check out our website for show notes, content, updates, and contact info at yorku.ca/science/observatory. Thanks for tuning in. Clear skies and have an excellent night.